Okay, B3 now. The same as which one? Yeah, that's all, yeah. So we want to know, again, just like before, for which values of x are the following defined? What? Dude, we did this type of question twice already now. Allowed, possible. What values of x can we use? Yeah. I guess I must have done this at a 9 o'clock class. You know? Dana, Soon, what are you doing over there? No,
Bad guy.
Troublemakers. Troublemakers.
No troublemakers, troublemakers.
Did you hear that? She's saying she's the troublemaker. Yes. Just one troublemaker over there with a yellow coat. Okay, so here, which ones are defined for? You need 2x plus 1 to be more than 0, and 3x plus 4 to be more than 0. So you get x must be more than minus 1 over 2, x must be more than minus 4 over 3. And now in part 2, we have to solve it. Right. So here, what do we need to do? Change the base. Should we change the 3 to a 9 or the 9 to a 3, or does it not matter? Yeah, it doesn't really matter, but if you ever had a choice, you should always try and make the base as small as possible. If you have a choice of going smaller.
Can we just take out the 9? Can we make 9 as 8 power 2 and then the 1 over 2?
Yes, but if you recall, that was your rule that you've seen before, but it's not in the formula book.
So we can't use it?
No.
What?
No, I told you this. But I showed you how to do it using the rules in the book. You swap it, and you change 9 to 3 squared and bring out the 2 and then swap it back. Sorry, man. Sorry. I'm just telling you what they tell me.
That's not fair.
I know it's not fair, but that's life. No,
Yeah,
you're not encouraging. You're not helping, Hussein. You're not helping. Okay. So what they would like to see here, it's actually all right. It's actually all right, Tal. If you did do that in the exam, I'd still give you the mark for it. Okay, but I'm not encouraging it. Okay. This is log 3x plus 4 over log 3, 9. Yeah? Is that okay? Yeah. So you get here log 3 2x plus 1. What's log 3, 9? 2. Now what do I do next? The next thing to do is to take this here and bring it up as a power. So it's gone. And then the next thing to do is now we can cancel the logs. So we end up with 2x plus 1 equals square root 3x plus 4. We square both sides to cancel the square root, and we get this when we square both sides. So we end up with this equation. Probably a 4 and a 3 like this, I'd say. no, maybe, sorry, maybe not the 3 here, I meant it on the other one, possibly 3 and 1 like this, and then a positive 4 and a negative 3.
Yes.
Yep. So you get x is 3 over 4 or x equals minus 1. Now if I go back to the first part, you need x to be more than minus a half and more than minus 1.33. So if I look at this, well, this one's definitely good. But this one here we reject. Can I go on to B part now? Yeah. So B part, the temperature of an oven is given as 18 plus AE minus KT, like that. Very, very, very similar to what we were doing before. They tell you at the beginning the temperature when T was 0 was 218 degrees, and then when T is 8, the temperature is 138. So we sub them both in to make 2 equations. So our first one is 218 equals 18 plus AE0, and then the second one is 138 equals 18 plus AE minus 8K. This one is really, really good because it actually gives us the A straight away as 200. Straight away we get the A. So I can sub that into the second equation and I get 138 equals 18 plus 200 E minus 8K. So I get 138 minus 18 is 120, and I get 120 over 200, 12 over 20, 6 over 10, 0.6 is it? 138 minus 18 divided by 200, 0.6, yes. So I get 0.6 equals E power minus 8K. We know how to cancel the E here with a log. So you have now log 0.6 over minus 8. That's the K.
0.06. Yes.
You're giving me the final answer, is it?
Yes.
Yeah. Does it say anything about number of places? No. So we'll just do our usual tree. 0.0639. And the A equals 200. And then the last part here, B part 2, is find the temperature when it is at 12 minutes have passed. So the temperature is 18 plus 200 e to the minus k t, which is 12. Okay, so we just type that in. And we get 111 as the found temperature. Yeah?